Okay, so we continue with our proof of the Allenberg's formula for the wave equation. So in my previous video, we do step 1 and step 2. Now we're gonna go backwards. So what does it mean? We need to take the Fourier inverse of this guy. So what does it mean? So we have to do, let me put it in orange. We have to take the Fourier transform inverse of capital UKT, okay? And this is going to be equals the Fourier transform inverse is linear. I have to take the Fourier transform inverse of fk divided by 2 e to the ickt plus e to the minus ickt plus the Fourier inverse of gk over 2ick e to the ickt plus e to the minus ickt. Okay, so that's what we're gonna do. So let's start with being positive. So the Fourier inverse and capital U is the Fourier transform of the small u. So by the inverse Fourier theorem, this first guy is just gonna be u xt. Okay, so f inverse cancel with this u because u is the Fourier transform of the small u. So f Fourier inverse with u. So we're gonna get u on this side. So here we get uxt equals. So now we have to do the Fourier inverse of this guy. So that's what we're gonna do now. So we're gonna do, now let's find the Fourier inverse of the first guy, that is fk divided by 2 plus gk 2ick. Oh, okay, sorry. So not exactly, okay, sorry, I say this. The idea is to, oh, okay, no, that's good. So this one, fk looks like that, but right now it doesn't look like that, right? So I need to make it look like this. So right now I have everything mixed. So I need to put S with F's and G's with G's. So right now I have this guy. So I'm gonna make it equals. So I got f of k e to the ickt over 2 plus gk e to the ickt divided by 2ick, right? And then I have plus f of k divided by 2 e to the minus ickt minus g of k 2ick e to the minus ickt. Okay, so ickt, gkt, okay. So now we put f with f's and g's with g's. So when I factor, I got f of k divided by 2, then e to the ickt plus e to the minus ickt, and then I get, when I factor here, plus gk over 2ick, I get e to the ickt minus e to the minus ickt, right? gk to ick e to the ick t plus, yeah, plus or minus, let me see. Yeah, it's good. It's minus. Okay, I have a typo here in my notes. So that's minus. Okay. So now we proceed as I said. So now this is UKT. So we take the Fourier transform for each of those. Fourier transform for this one. Fourier transform for this one. And Fourier transform for this one. Okay. So let's find the Fourier transform of the first one then. So the Fourier transform of the first one, Fourier transform of fk divided by 2 e to the ickt plus e to the minus ickt. Right. So what is this? By definition of Fourier inverse transform, this is 1 over square root of 2 pi, right? And let's take the 1/2 outside, 1/2, and then we got the integral of e to the ikx times f of k, and then we got e to the ickt plus e to the minus ickt dk. In this case, dk, because it's the inverse Fourier transform. Okay, so far I haven't done too much. I just applied my definition of Fourier inverse, and I just took the 1/2 out. Okay, that's my definition of Fourier transform inverse. So now I multiply these guys, ikx with ickt and these guys, and I'm gonna separate the whole thing. So I'm gonna take my 1/2 out, and I'm gonna get 1 square root of 2 pi of the integral of e to the I k x plus ct, and then I put f of k dk, then plus 1 over square root of 2 pi integral of e to the minus, ikx minus ct, and this is f of k dk. Okay, but if you, by the definition of Fourier transform or the inverse Fourier transform, you see this is pre-calculus, so you can stop your video and tell me what do you think this is gonna be using the definition of Fourier inverse transform. So stop the video. So now you're back. So this guy is my new x. Okay, so the first part is a small f x plus ct, plus the second part is a small f x minus ct. Okay, and that's my first part of the formula. Remember the Allenberg formula? I got the first part. Now the second part, and then we're done. Okay. So now the second part. So for the first part I got this one. I already got that one. So the next part now is this one. So that one has some integration tricks, but not that bad. Okay, so because we know what we want, so now next we want to do the Fourier inverse of gk over 2ick e to the ickt minus e to the minus ickt, right? So by definition of Fourier inverse, this is 1 over square root of 2 pi, and the integral of e to the ikx of gk, and then I'm gonna take the 2c out. The 2c out, I take it out, and I got e to the ickt minus e to the minus ickt dk, and then I have over 2ik. Okay. So two, I don't know, not two, just ik, right? Yes. Now I separate the integral in two, so I got 1 over 2c, and let's put it like this: 1 over the square root of 2 pi integral of e to the ik well, okay, let's multiply, so it's clear. Gk, I multiply this guy, so I got e to the ikx plus ct minus e to the ikx minus ct dk over ik, right? So I just multiply ikx times these guys, right? Yeah, correct. I just multiply and then factor ik, okay? And now this is the important step for this part, because what I'm gonna do now is 1 over 2c, and this is I'm gonna notice that this guy is just an integral. So this is gonna be 1 over the square root of 2 pi integral of gk. But if you look carefully, this is by the fundamental theorem of calculus. This is iky between x minus ct, x plus ct, dy dk. You see it? So this is the derivative, the antiderivative of this is iky divided by ik. Now I replace y by x plus ct minus x minus my e to the I x minus ct, so I obtain, so this integral is that. We have done it many times, right? But now this is complex, but not a problem, because fundamental theorem of calculus applies. So now I have gk and e to the ky, right? And now what I'm gonna do now is, so let's move this gk inside. So gk is here, but it can be moved inside, right? Because I have dy, so this is a constant, so I can move it inside. So let's put it gk here. And now we're gonna use again our Fubini's theorem that you saw in calculus 3, that says that you can interchange these two integration if the whole integral exists, and by we are assuming the solution exists. Okay, so since the solution exists, that's this should be, this integral exists. So we get 1 over 2c, and then we interchange to 1 over the square root of 2 pi integral, and then outside we have x minus ct, x plus ct. Now we have outside dy, and now inside we have integral of e to the iky gk dk. Okay. So stop the video, and this is from minus infinity to infinity. So this was minus infinity to infinity. So stop the video and tell me what is this guy. So look at it, and the answer is sorry, this guy with, let's put this 1 over square root 2 pi inside over here. 1 over square root 2 pi over here. So now, what is that guy? So that guy is a small g o y. This is because this is the Fourier inverse of capital G. But capital G is the Fourier of small g. So the Fourier inverse with the Fourier cancel. So I get x minus ct, x plus ct, g o y, dy. Okay? So with that, we had concluded that we had proved the second part we needed. We now have proved this part. So we had proved that indeed we get here the Allenberg's formula. I don't know, we're gonna write again. Okay, so yeah, so this is, it's tricky, but it gives you a really good feeling of what is going on. What are the tricks to get this really important formula? It's one of the most important formulas for this class. So let me see, so I can stop it now.